In this problem, we need to calculate the concentration of the major ion remaining when 10.0 milliliter of 0.200 molar nitric acid with a strong acid are added to 20.0 milliliter of 0.250 molar of sodium hydroxide, which is strong base. And I want you have a clear picture what's going on in here. That is, we have 10.0 milliliter of acid mixed with 20.0 milliliter of the base. So what's the final volume of the solution? So we have 10 milliliter of acid mixed with 20 milliliter of the base. The final volume, the volume of the final solution is 10 plus 20, 30.0 milliliter. So keep this in mind. Now let's go ahead to work this out. So use the ICF table, initial, change, and final table. We need to figure out initially how many more of nitric acid, HNO3, that is 10.0 milliliter, that's the volume, times 0.200 molar, that is mole per liter, and we convert milliliter to liter, that is 1 liter corresponding to 1,000 milliliter. And for the sodium hydroxide, the initial mole number is 20.0 milliliter times 0.250 molar, and time the conversion between mole, liter and milliliter. So how many more of sodium nitrate we have initially? 0 mole. And because it happened in water solution, we don't look at the more number of water right here. Okay, then we do the calculation. Initially, we have 2.00 times 10 to the negative 3 more of nitric acid, and 5.00 times 10 to the negative 3 more of sodium hydroxide, and 0 more of sodium nitrate. And because this is 1-to-1 ratio, and we have a different mole number of acid and base, and we can see that here nitric acid is the determining limiting reagent. That means this acid will be used up before the sodium hydroxide being used up. So as a result, after the completion of the reactions, all the nitric acid will be consumed, but we do have some part of the sodium hydroxide remaining, and plus the product. So with nitric acid is as the limiting reagent, the change of this limiting reagent is 2.00 times 10 to the negative 3 more. That means all of the acid will be reacted. And how many more of base will be consumed? Based on the ratio nitric acid and sodium hydroxide, we know that we'll have same more number of the nitric acid of the base being reacted. And how many more of sodium nitrate produced? They're all 1-to-1-to-1 ratio. So therefore, we have 2.00 times 10 to the negative 3 more of sodium nitrate produced. As a result, we have none of the sodium nitric acid left out, but we have 3.00 times 10 to the negative 3 more of sodium hydroxide. That's right here. In the final solution, I have 2.00 times 10 to the negative 3 more of sodium nitrate in the final solutions. Now we have the more number of this species In what? In the final 30 milliliter solutions. So in this 30 milliliter solutions, we have no acid. We have so many more of sodium hydroxide and so many more of sodium nitrate. Now let's figure out what's the concentration for major ions. So what are those major ions? Because we have no nitric acid in the final solution, so therefore this is a strong acid. So therefore we do not have H+, and we do not have nitrate ion from this compound. But we have NaOH, sodium hydroxide, so therefore we have sodium cation, Na+, and we have hydroxide anion, OH-. And we also have sodium nitrate. Therefore, we have a sodium plus, again, from sodium nitrate, and we have nitrate ion, nitrate anion, NO3- from the product. Now let's figure out the concentration. So the concentration of sodium hydroxide is the mole number of sodium hydroxide. We divide that by the volume, and we convert milliliter to liter. Okay. This gives us the concentration of sodium hydroxide as 0.100 molar. Similarly, we have concentration for sodium nitrate as 2.00 times 10 to negative 3 mole over 30.0 milliliter. I'll do the conversion a little bit differently, probably easier to see, and give us the concentration 0.0667 molar. Okay, now the last step, how can we figure out the concentration of major ion? And here we can see that we have a sodium plus from sodium hydroxide, OH- from sodium hydroxide. We have a sodium plus from sodium nitrate and nitrate minus from sodium nitrate. So the easier stuff first. The concentration of OH- is actually equal to the concentration of sodium hydroxide, and give us 0.100 molar, and the concentration of nitrate ion equal to the concentration of sodium nitrate, and give us 0.0667 molar. But the concentration of sodium plus is the sum of the sodium plus from sodium hydroxide and the sodium plus from sodium nitrate. Okay, so one more, too many 6 here. Okay, erase all of this. Write again, 0.0667 molar, and the concentration of sodium plus as a major ion in the remaining final solution is 0.167 molar. So as the result, we have 3 major ions in the remaining solution. One is hydroxide, the concentration is 0.100 molar. Nitrate, the concentration is 0.0667 molar. And the sodium plus, the concentration is 0.167 molar.